Okay, so this is question number 18 from unit 4.4. We have a word problem here that we need to solve. So when you solve a word problem, the first thing you want to do is read that problem carefully and make sure you understand it. You can't solve a problem if you don't know, if you don't understand it. So we do what we call problem solving strategy. We have a strategy. Okay, involves 4 or 5 main steps. The first one again is to read and understand. You may have to do that a few times, like I said, depending on the complexity of the problem and the length of it. Read, understand. So before you start writing the equation or answering, you want to understand your problem first. Number 2 is to label the variables or label the missing numbers and translate that into an equation. So translate into math equations or in this case, you're going to have a system. Okay, number 3, what was the third step again in solving? Once after you translate the problem into an equation, what do you do? What a system?
You solve.
That's right, the solve with the solving part. So the solve, you gotta solve your problem. Finally, number 4 is to check, right? These are the main ones, the main steps in solving a word problem. Pretty much any word problem, the same concept will apply. All right, so good. So let's read the problem now and try to understand it. Meanwhile, I'm going to label the missing amounts or quantities as we go. So during a Broadway, so there's 2 Broadway shows, okay? And during Broadway runs of A Chorus Line and The Beauty of the Beast, there were 676 fewer performances of Beauty and the Beast than of A Chorus Line. There were a total of 11,598 performances of the 2 shows. How many performances were there of each show? Okay, again, well, I understand we have 2 performances, 2 shows. We have show X and show Y. One of them is was displayed or performed more than the other. So let's call the first one here the chorus line. Let's call it X. So the number of performances of this show, and the Beauty of the Beast, let's call that Y. The number of the performances of that show, so X and Y. So we understood the problem. So in the second phase of translating the problem into mathematical equations, first you want to label the missing numbers or the variables. Okay, so one is X, the other one is Y. So here's a key thing here. There were 676 fewer performances of Y than X. That's important. We're going to translate that into an equation. The second part, there were a total of 11,000 and some change of the 2 shows. So that's another equation. So this is one equation. This is the first equation. And this is what we need to do. Find how many, okay? That's exactly what we need to find, how many performances of each show. Each show, we have 2 shows, X and Y. So we're going to translate this into a system of 2 equations. All the information needed is given. We just need to translate that into a system, a linear system. Once we have that system, the rest should be easy. We just need to solve it. So the important part is understanding the problem and getting the right equation. If you don't get the right equations or system, you will most likely not get the right answer. So let's translate. Maybe the second part is easier to translate the second sentence. There were a total of 11,598 performances of the two shows. How do you translate that into an equation? If this is the number of the first show, this is the number of the performances of the second show, both together form or were performed 11,000 times. How do you put that into an equation in terms of x and y?
Is it 2x plus y equals 11,598?
Why the 2x?
Because of the two shows.
No, the two shows we mean x and y. Chorus
Okay.
line, Beauty of the Beast. So if x was performed, if the first one was performed x times, the second one was performed y times, how do you put that into an equation with x and y, knowing the total of performances of the two shows? So this was performed x times, this is y times.
Is it x plus y equals 11,598?
That's right, that's all there is to it. So x and y, so the two shows, x plus y, both were performed 11 times, but were they performed evenly, each one half of this, or was there a difference between the two? In other words, were the two shows performed an equal number of times?
I don't know, maybe different?
Different. If you look over here, it says the first one, x, okay, there was 676 fewer performances than Beauty of the Beast than the chorus line. Which one was performed more? There were 600 fewer performances of Beauty and the Beast than the chorus line. So y was performed less than x, right?
Yeah.
So what does that mean? So y, how much less? So if we write this into an equation, we say, so y was performed less than x. How much less than x?
676?
That's right, 676. So y, again, was performed fewer than the other show, than the chorus line. How much fewer? Again, the problem gives you that information. Fewer, so that's a subtraction here. So whatever the number of x was, which was performed way more times, so chorus line was performed way more times, so it's a larger number. But y, or the second show, was only performed whatever the x was minus this. So it was performed 676 times fewer, the minus, hence the minus, than the first show, which is the chorus line. That's it. That's our system. We just basically put this into two equations. Okay, so we did this part. So we passed this, we translated. Now we just need to solve this system. We're going to use the same method we used earlier. What was the method called again? What method did we use earlier to solve the system?
Was it substitution?
That's right, substitution, exactly. Because it's you can use either method, but it doesn't specify, let's use substitution. So solve by substitution. So what do you substitute and where? Look at these. Which variable is substituted and in which equation? Equation 1, equation 2.
You can put equation 1 into equation 2.
That's right. Which variable specifically we're gonna
so the y you plug it in and put x minus 676.
That's right. So you go to the equation, you look for the variable that's by itself. That's the variable that goes into the other equation. If you don't have a variable by itself, then you'll have to isolate one. You'll have to isolate one of the variables in order to plug it into the equation. Okay, so in this case, the y is already by itself. We're going to plug it into this. So plug y into equation 2. That's our first step. So we're going to get this equation 2 turns into the x plus the y. But instead of the y, what do we write?
X minus 676.
That's right, because y equals this. We're going to write x plus x minus 676. So that's basically the y. And the rest of the equation remains the same, 11, 5, 9, 8. Okay, again, this is the y. Okay, we're solving the y from here. And I'm just going to need to solve this for the variable that's here, which is x. So solve for x. What do you do here? What's the first thing you do to simplify this?
Remove parentheses.
Parentheses.
Okay, so the parentheses are irrelevant. Okay, let's do that. So plus, basically when you have a plus in front of parentheses, it's like a plus 1 times something. You can say, basically it won't change anything. B minus 676. What else?
Then you put 2x minus 676.
Exactly, you're gonna combine like terms. So you have 1x, 2x minus 676, 11, 5, 9, 8. What else?
Then you add the 676 on both sides.
Okay, that's right. We're gonna get rid of this by adding it. Okay, can someone do the math for us quickly and add these two? So these cancel out. So you end up with 2x. And that will be equal to
12,274.
how many thousand? 12.
12,274.
Okay. Very good. And the final step.
You divide by 2, right?
Okay, whatever you got there, divided by 2.
6,137.
That's right. So that's x. What does x represent again? The number of what?
Chorus line.
Number of shows.
Which show specifically?
It's the A chorus line.
That's right, for the first one, the chorus line. So this is the chorus line, the number of times it was performed. Now, are we done solving?
For y.
We're gonna solve for y, that's right. Still not done yet, so we're gonna have to solve this for y. Okay, so the first
So you
step,
use the first equation, right?
that's right, that's right.
The y equals x minus 676.
That's right, so find y. First step again, plug or substitute y into one equation. Plug or substitute, that's why it's called the substitution method. Solve for the resulting variable, then you gotta find the other one. So plug, now that we have x, plug x into, we have two equations, we can use either one, but which one seems to be convenient and easier from here?
The y equals x minus 6.
That's right. We're looking for y, okay? We're looking for y. We can use either one, but this one seems convenient, already has y by itself. We're gonna need to plug the x here, x we know. So we're gonna put the x here and find the y. So y will be, plug x into equation 1. Or you can use the other one, but this one is easier. So x, again, is 6137 minus, do the math again for this one. We'll on it.
5,461.
5,000.
5,461.
Okay, so this is the number of the performances of the Beauty and the Beast. So we got the X, we got the Y. What's left to do?
Check.
Check. Let's see if these numbers add up, if they make sense. If not, something's wrong, we'll have to fix it. So let's do, so these two numbers, according to the problem, they should add up to what?
11,500.
That's right, they should add up to 11,000. The total number of shows is 11,000. If you add X and Y, we must get 11,598. Let's see that. That was our second equation, X plus Y should be 1,100.
It does.
It does, okay. Very
Yes,
good.
you add them both together, it totals up that amount.
That's right. So check this one. So it'll be the X again was here 6137 plus the Y, which is this. And we say, is it equal to 515 or 11,598? Yes, in fact, it does add up. We're gonna trust Lilanet, right?
Yes.
Should we trust you, rely on you?
Yes.
I was trusting a student earlier with a not different class, and they didn't do the math right, and I told him I wouldn't trust him again.
I did it. I'm doing it. I'm doing as we're doing it.
Okay, we'll take your word for it, okay?
Okay, dokie.
If not, I'll find you. You know.
Uh-oh.
That's not a problem. I have you next semester. It's okay.
Run away, Lynette.
It's easier to find you then. All right, so we have X plus Y this, but we have to check the other equation as well. So the other equation, a little more complex than the first one. So what actually, what is it? What's the other one? Yeah, so kind of similar. So the first one was X or Y. So this time we're gonna plug the X here, minus 676. So let's check that on the side here. So the Y is again here. So 5461 minus or equals the X, which is down here, 6137 minus 676. Not sure yet. That's what we're going to use this question mark or equal sign. So is this equal to this? Okay, click on that. You want to check this?
I did check that one. That one totals up to the same thing, the 5,461. They both equal.
That's good. So that's exactly what we wanted. So that's the last part of checking. So this one 61 is in fact equals to this difference 5461. So that checks, the first one checks, and the problem is done. So that was the last step in the solving strategy. Check the problem, the numbers add up. So that was it. Okay, did that make sense to everybody?
Yes.
Do you want me to answer that question?
I'm sorry, go ahead, one at a time.
Do you want me to answer that question?
I mean, did you get it? Did you understand it?
Yeah, to an extent I did, yeah.
Okay, you know, it's a little long, but each step in itself, if you break it down into one step at a time, you basically each step in itself is not that bad. Everybody else, any questions about this problem? Did everybody get it?
No. Got it.
We can recap.
I didn't get the second one. It came out wrong when I did it.
The second step or the second?
The second check.
Oh, the second check. Okay. So this one, that's what the equation was. This is we basically used both of these. This one was easy to check, we got this. Second one, we put the y here, we put the x here, and they basically subtracted the same thing. So the y, we took the y from here, plugged it into the x, into the y. Took the x from here, 6137, and minus the rest of the equation. So we subtracted these, and we got that number. This is the same as this. So the two sides are equal. That means the numbers check. Okay. All we did was plug x and y in both of these, and we get two equal sides. So that means the numbers actually add up. Okay.
Oh, okay. I got it.
Very good. So that's basically how you solve linear systems by substitution. So you could, the problems are not always written in math format, as I said earlier. You may have to translate them into mathematical equations. You may have to translate them first. So if it's a word problem, depending on how complex or how long the problem is, read it as many times as possible, or as many times as it may take you to understand it. Once you understand it, you go to step 2, which is labeling and translating the problem, which we did here. We call this X and Y. You could call them any letters, A and B, or you could call it C and B. Maybe C and B, if that makes more sense, more meaningful. These two are more meaningful to the problem. Once you get your system or equation, solve that using one of the methods we learned. Okay, and after that, you don't forget to check your answer. See if your numbers make sense or not. Just like last time, you remember we had a problem with the number, one of the word problems. Always check your answers to make sure everything works. Okay, let's see here. Geneva has a question, first degree equation. So I want to keep this here actually. Oh, you know what? I'll post this later. Okay, I'm gonna post this video later anyway. So I'm gonna clear the board now. Are you guys done with the board? Can I clear it?
Yeah.
Everybody?
Yes.
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 Okay, I'm gonna clear this. And Geneva has a question. Question is, which unit is this from, Geneva? What's the question number?
This is chapter 2, section 2.1. This is the hard book. This is the textbook.
Mm-hmm.
Homework 7.
Homework 7. Question? Question
number 74.
74. Can you look at 75?
Okay.
Is it similar?
No,
73.
because it doesn't have the
Right.
number outside of the parentheses.
What about 73?
73, yes.
Okay, let's do 73 because you will do 74 for the homework, right?
Yeah.
All right, give me 73. Just say it out loud for me.
All right, parentheses 5y plus 6 parentheses.
Okay.
Minus parentheses 9. No. It's minus in between, then parentheses.
Minus here, right?
Mm-hmm.
Okay. Go ahead.
Wait. Yeah. Okay. 3 plus 4y.
Okay.
Equals 10.
10. All right. So you have a linear equation, just one equation, not two, unlike a system as we saw earlier. So first, you want to clear the parentheses. What's in front of these parentheses here?
1.
That's right. We have an invisible one. So basically, you're going to distribute that 1, which won't change anything. Let's just write these. So 1 times anything is itself, is that thing itself. So these two won't change. What is this? The negative 1 in front of the parentheses. You can think of that as?
Negative.
Negative 1. So we're going to distribute that negative twice. Negative 1 times 3 would be?
Negative 3.
That's right. You have negative 1 times positive 4. Okay.
-4.
-4 and the
Y.
y. Okay, you want to clear the parentheses. What do you do next?
Do you minus the -4y to the 5y?
That's right. We're going to combine these like terms. At the same time, we're going to combine these numbers because they're like terms. 5y take away 4, right? That would be
1y.
Y.
just y or 1y. What else?
3 plus 3y.
Plus
3
plus 3
equals
and
10.
10. One final step to isolate the y.
Minus the 3 to the 10.
That's right, -3 on both sides. That, so y is 7.
Okay.
Okay,
That was
so that's the first degree equation. You want to clear the parentheses first, combine like terms, and isolate the y.
copy.
Okay, is everyone okay at this point? All good?
Yeah.
Yes,
Can I
Professor.
give you one, Professor?
Let's see how many minutes we have left. Let's see here.
Okay.
All right, is there
11.
11 minutes? Okay, go ahead. Is that an equation like this?
No, it's from, I think, homework 12, from the book 208.
2.8.
From the book, the page 208. It was
2.
207, but then the actual numbers is on 208.
Okay,
Page 208,
okay.
and the one you gave us was 30, but looking at 29.
29. Are they similar?
Yeah.
Okay, got it.
So it's open bracket 5, comma, dash, close bracket.
5. Say it again, I'm sorry.
Dash. Not a comma.
Not slash dash.
Comma.
Decimal point or comma?
Comma.
Like this?
It's a comma.
Okay, go ahead.
Yeah, and then you put a line because I guess you need to plug in something in there, close bracket.
Oh, okay, I see what you mean. This is an empty thing, right?
Okay, and the question is complete each ordered pair for the equation y equals 2x plus 7.
Y equals
2x plus 7.
2x plus 7. What's in the second pair?
That's it.
You don't have anything here? Was it just one pair?
It's just one pair.
That's it.
All right. And basically, what do we call the first variable here? What's the first variable?
I guess x,
That's right. Second one is
y.
y.
Yeah, I was going about it already. Okay.
We did something like this here. So we're missing the y, right?
Mhm.
So we're looking for the y. So what do we do with this pair and the equation in order to find the y?
I'm guessing plug it in.
What do you plug exactly?
The 2x plus 7.
So y, we're looking for y. So we need 2 times what? Do we know the value of x?
5.
That's right. So we're going to plug the 5 here. Okay. So y will be,
What?
so the equation is this, it has 2 variables. We're looking for y, but we need to know the other, which is given
Oh,
here.
which is x. Okay, okay. I think I get it now. Okay.
2 times 5.
Yeah, that 5 looking sick. It needs to go to the doctor.
Yeah. Something wrong with this. My screen. Oh, it's gone. Okay, so it was 2 times 5 plus 7, right?
I can't see your screen.
All right, it's gone. For some reason, it closed. My mouse is acting up. Okay, so that was my mouse stopped working. Oh, there it is. It's back.
Okay.
Oops, sorry, again, so 2. Okay.
That's it?
That's it. Yeah, that's what your question said, right? Just complete the pair, just one pair, right?
Yeah. Okay.
Pretty much it.
Got it.
Okay, is everyone on board? You guys got all that?
Can I give one more that is a little bit different than this? Let me find it. As I took a
Okay.
picture of it so I can have it. It entails having boxes, an X on one side and Y on the other side.
Mm-hmm.
See, it's number, you gave us 42,
Mm-hmm.
so we can use 41. So the same page, 208,
Okay.
number 41.
Okay, give me the problem.
X equals 12.
Okay.
Now, just like you play in a game of tic-tac-toe, you have X on one side and Y on the other side. A straight line in the middle and 3 lines across. One straight line coming down.
Is there a graph?
That's some type of graph. I don't know what it is.
Uh-huh. And then?
And then, no, you have to put like 2 more lines again. So make that straight line a little bit longer.
Okay, let me go to the page. What unit again was this from? I'm gonna go to it from here.
Page 208 in the book, number 41.
The unit. Can you
Unless,
speed it up?
I don't know if you can see my screen.
Yeah, it's not clear. What's the unit number? It's easier that way.
It's exercise 3-1.
Okay, I see now what you mean. It's a.
You have to find the table value.
Got it. I got it. So you have.
Okay.
It's not a graph. It's a table.
Okay.
Right. Like
Yeah.
this. You have some values here. Let's say you have 2 or 1, whatever values you have. Same thing.
Yeah.
So basically, just.
Well, I have 3, 8, 0 on the Y side and nothing on the X.
Okay, not a problem. Something like this. Basically, we have X. We need. This is the equation. It doesn't have Y. Okay, so the X when the Y is 2. So this is basically the equation. It does not change. The X is fixed no matter the Y. So even if the Y is 2, X does not change because we don't have Y here to plug this into. So it does not change. It's itself X, X, X. This is basically a line that looks like this. This is a line that's vertical. Okay, so this equation here only has X. When the equation has X only, the line is vertical. So the X does not change across the whole line. But does the Y change? The Y is 1, 2, 3, and so on. Here it's -1, -2. So the Y doesn't. The Y changes as you go up. For example, the Y here is 1, 2, the Y here is 3, and so on. But the X is fixed. It goes 3X and that's it. So for any value of Y, the X will be the same. Okay, so for any value of Y, for example, let's say maybe a 9 here. Okay, if Y is 9, what is the X on this line?
12.
12, exactly, will always be the same, will not change, okay? So that's what
So that's all I had to do, just plug that in?
that's it. There's no plugin, there's not even plugin, just put the numbers here because this equation.
Yeah, that's what I mean. Just put the numbers in.
That's right, the X is fixed. It does not change because the line is vertical. So remember this, X by itself, that means the line is vertical. All right, I believe that's it for today. So I'll see you again on Wednesday, or I mean Tuesday next week. I'll post the review sheet sometime, maybe tomorrow. And make sure you complete all your homeworks. You only have 3 weeks left. The final is in 3 weeks, the last Thursday of this month. We're gonna spend the next 2 next 3 weeks, basically finishing up all the homeworks and reviewing for the final. It's going to be 2 more homeworks and we're done. It's going to be 19 and 20, which I'm going to post on Tuesday, and that's it. The next 3 weeks will be just for that and for reviewing and catching up with everything.
Mhm.
Okay, while you're still here, let me check the attendance. So again, as you study, go over the resources, the videos. I'm gonna post this lecture itself. You can rewatch it if you want. Over all the stuff that's available for you. We're running out of time. Let me take the attendance quickly before we get disconnected. Who's here and who's not? Raise your hand if you're not here.
My hands are up.
I said raise your hand if you're not here.
I did.
If we're not
Doing
here,
the opposite. I am doing the opposite. My hands are up.
All right, Asaduva. Asaduva, not Janaba.
Yeah.
Anna.
Here.
Juan is not here. Santiago. Santiago. Hannah.
Santiago.
Hannah.
Here.
Chadley. Chadley. Alize. Not here. Malik, not here. McGranez, here. Maury,
yeah.
here.
Yeah.
Just now, not here. Jermaine, here. Angel, here was here at least. Layla Ned is here. Rohan, not here. Quentin, not here. Diadra Sadukat.
Yes, here.
Good. We made it right on time before we got disconnected. We're going to get disconnected at any minute. Have a good weekend. Everybody stay safe, and I'll see you next week.
You
Yes,
too.
sir. Thank you.
Bye.
Thank
Bye,
you.
everyone.
Have a good day.
Bye
Bye,
bye.
guys.